Students, in last video we have discussed about the vector and its types. Now try to understand about the multiplication of vectors and addition of vectors. The multiplication of vector by the real number. Here we are multiplying a vector a with a positive number lambda. It gives a vector whose magnitude is changed by the factor lambda. But if we will see about its direction, the direction is the same as that of a. See the equation, lambda into a is what? Lambda into magnitude of a if lambda is greater than 0. So for example, if a is multiplied by 2, the resultant vector is what? 2a. But it is in the same direction of a and has a magnitude twice of a. You can observe in figure, we have taken the vector a and just we have multiplied by 2. So the 2a, 2 into a, that is 2a. But if you will observe the direction is what? Same. Multiplying a vector a by a negative number lambda, it gives a vector lambda a whose direction is what? Opposite. In previous case the direction is the same, but here the direction is opposite to the direction of a and whose magnitude is minus lambda times a. So observe the equation, lambda into a. Lambda we have taken here negative number, so minus lambda into magnitude of a if lambda is less than 0. Here we have to multiply the vector a by a negative number. Here I am taking the minus 1 is a negative number. So minus 1 into a is what? Minus a. And minus 1.5 into a, that we can write minus 1.5 times a. Observe in figure, we have taken vector a into minus 1. What is this? Minus a. But observe the direction, it is in opposite direction. Minus 1.5 into a, that is minus 1.5 a, that is in opposite direction. So this is the multiplication of vector by real numbers. Now try to understand addition and subtraction of vectors. Addition of vectors. For that we are using a triangle law of vector addition. Two or more vectors may be added graphically or geometrically by using the law. The first law we are taking here, the triangle law of vector addition. Here, if the two vectors can be represented by the two sides of triangle taken in a same order, then the resultant vector is a third side of triangle taken in opposite order. Try to understand here with the help of figure. Here we have taken vector A, then vector B. So, to add vector B to vector A, move the vector B parallel to itself so as to place the tail of B on a head of A. Observe it carefully. We have just added. So the resultant vector that we will get here, OR. So you will observe in figure, the OP is a vector A and PR is a vector B. The resultant vector is what? That is the third side of triangle. In statement we have seen that if the two vectors can be represented the two sides of triangle taken in a same order, then the resultant vector is a third side of triangle taken in opposite order. So here the vector A is one side of triangle and vector B is also one side of triangle. So here we have taken the two vectors by the two sides of a triangle. So the resultant vector is a third side of triangle, that is R is equals to A plus B. So OR, it is a resultant vector that we can write A plus B. This graphical method is also known as head to tail method and it is also known as the triangle law of vector addition. Now try to understand commutative property of vectors. Here the resultant vector will be the same even if A shifted to place on B. See here we have taken the two vectors here. Observe it carefully. The first we have taken the B vector and then we have shifted the vector A. So OP is a B and PR is what? A. The resultant vector according to a triangle of vector addition, it is what? A third side of triangle, that we can take R is equals to what? B plus A. Why? Because the B we have taken, it is a first, and then we have added A. So we can write a resultant vector R is equals to what? B plus A. Observe in next figure here. Here we have taken a vector A, vector B. Now we have shifted the vector B. Okay, so the third side of triangle is what? OR. So what we can write here? The vector A plus vector B, because we have taken OP is A and PR is what here? B. So the resultant vector is A plus B in second case, and in first case the resultant vector is B plus A. So resultant vector R is equal in both magnitude and direction. We can write the equation for R. R is equals to A plus B is also equals to B plus A. We have just changed the order. The above relation is also known as the commutative property. Here the property of vector addition is independent of the order in which the vectors are added. It is called the commutative property of vector addition. So R is equals to A plus B, and that is also equals to B plus A. So we have observed in figure number 1 and figure number 2. Let us try to understand about the associative property of vectors. For that we have taken a vector A and vector B. We have to take here three vectors, the vector A, B and C. Observe it carefully. B we have shifted. Then according to a triangle of vector addition, we can write that OQ is equals to A plus B. The OP is a vector A and PQ is a vector B. So OQ we can write A plus B. Now we are adding a third vector, that is a C vector. So the resultant vector we have got here OR, that we can write A plus B in bracket plus C. So you know that here also we have used the triangle of vector addition. R we have got A plus B in bracket plus C. Observe the second figure. Here we have taken the vector B and vector C. Then its resultant vector according to a triangle of vector addition is what? BC, because PQ is a B and QR is a C. So the resultant vector PR, it is B plus C. Now this B plus C we have added to the A. Now you will observe they form a triangle. So we can write it resultant vector R is equals to A plus into bracket B plus C. So OP is a vector here, PR is a B plus C vector, and the resultant vector we have got, it is a third side of triangle. According to a triangle of vector addition, we can write R is equals to A plus into bracket B plus C. So the resultant vector R is equal in both magnitude and direction, and that we can write the equation R is equals to, you will see in first figure what we have written, A plus B in bracket plus C, and it's also equals to A plus into bracket B plus C. So this type of relation of addition, it is known as associative property of vectors. You will observe this figure carefully. OP we have taken, it is a vector A, and PQ we have taken, it is a vector B. So OQ we can write A plus B according to a triangle of vector addition. Observe the triangle PQR. In this triangle the PQ is B, QR is a C, and the resultant vector, it is what? PR, that we have taken B plus C according to a triangle of vector addition, you know it. Observe the triangle OQR. In this OQ is A plus B and QR is C. So we can write its resultant vector is what? R is equals to OQ plus QR, that is A plus B plus C. So this is about the associative property of vectors. We have seen its equation also. R is equals to A plus B in bracket plus C, that is also equals to A plus in bracket B plus C. Now try to understand about the parallelogram law of vector addition. If the two vectors can be represented both in magnitude and direction by the two adjacent sides of parallelogram, here we have to take two adjacent sides of parallelogram, then the resultant vector is completely represented by the diagonal of parallelogram passing through a starting point of vectors. Try to understand with the help of figure. Here we are taking a vector A, vector B. You will observe it carefully. So OP is a vector A and OQ is a vector B. So here they have formed a parallelogram. The name of this is OQRP. According to a statement, if the two vectors can be represented both in magnitude and direction by the two adjacent sides of parallelogram. Here we have taken OP and OQ. These are the adjacent sides of parallelogram. It is represented by a vector A and vector B respectively. Then the resultant vector is what? A diagonal of a parallelogram which is passing through a starting point of that two vectors. So what is the resultant vector here? OR, which is starting from that O. Okay, so R is equals to what we can write, that is A plus B, that is a vector A we have taken and vector B. These are the two adjacent sides of parallelogram. Then the resultant vector is represented by the diagonal of parallelogram passing through a starting point of vectors. So you will observe it carefully. This OP and OQ, these are the two adjacent sides, and we have got the diagonal of parallelogram. It is a resultant vector and that should be passed from the starting point of these two vectors. So the diagonal represent the resultant or the sum of the given two vectors. So this we can also obtain with the help of triangle of vector addition. If the two vectors are represented by adjacent sides of parallelogram and the resultant vector is given by diagonal, and this type of method we are also knowing it is parallelogram method of vector addition. Now try to understand the polygon law of vector addition. Here this type of law we can use to obtain the resultant of more than two vectors. Here, if the number of vectors can be represented in magnitude and direction by the sides of polygon taken in the same order, then the resultant is represented in magnitude and direction by the closing side of polygon taken in opposite order. Try to understand here with the help of figure. Here we have taken the three vectors. Let us try to understand. The B we have shifted. According to a triangle of vector addition, we can write its resultant vector OP is A, PQ is a B, then its resultant vector is a OQ, that we can write A plus B. Now see, we have shifted the C vector, then again they have formed the triangle. You will observe the triangle OQR. OQ is A plus B and QR is a C. Then the resultant vector is what here? R is equals to, add this A plus B plus C. So this is the polygon law of vector addition. So we have discussed about the multiplication and addition of vectors. Next time we will discuss the subtraction of vector. Thank you.